Welcome to Module 5. So in this first segment, we're going to talk a little bit about data modification anomalies. And so there are several different times where these anomalies will occur, and several different reasons as to why they will happen. So we're going to talk about some of these anomalies and then what we can do to fix them. So the first type of anomaly that we have is an insertion anomaly. And so these typically result from adding a record to a database where you don't have essentially all of the required data to input into the record. An example of this is if we have a database that has students listed out, and in this database it has the student, their ID number, the professor that they have, the department that they're in, their major, all of that kind of stuff. If we have a brand new student, we can enter in their name and which department that they're going to major in and things like that. But because they're a brand new student, they might not have a student ID number yet, right? So that's an example of an insertion an insertion anomaly, because we've inserted a new record, but we don't have all of the required information. In this instance, or in this example, the student ID, which is essentially the primary key. So that's a big issue. Then we have an update anomaly, and this typically happens from data redundancy. And so, an example of this happening would be if we have, kind of using the same example of the student, of a college student essentially, if the department name that they're in changes its name from, say technology to industrial technology, then there's going to be several different records that are going to need to be updated in order for that information to be accurate and consistent. And so this is what we refer to as an update anomaly. And then the next, or the kind of last most common anomaly is a deletion anomaly. And we've kind of talked a little bit about this before, right? At least a similar situation. So, an example of this is if we have a professor, again using the same example here, if we have a professor that retires and then we're going to delete his record from the database, if he has any students that are tied to him, that's going to cause a deletion anomaly, because now they have students that are not tied to a professor, and they're kind of just orphaned, right? Another reason why referential integrity is very important. But if that does happen, that is what we refer to as a deletion anomaly. And so the way that we can kind of address these anomalies and prevent them from happening is really kind of more about standardizing our database. It's what we refer to as creating normal forms. And so we're going to talk about 4 different normal forms, and it's just sequential normal forms, meaning first normal form, second normal form, third, and fourth normal forms. And so in the first normal form, we can say that a table, a relation, is considered to be in first normal form when it doesn't contain any repeating groups, essentially more than one value in an attribute, right? Each column contains atomic values and it has no duplicate records. When this is done, this is what we refer to as being in first normal form. Just realized I was cutting off my screen there. Sorry about that. So that's first normal form. Second normal form is a relation, a table. We consider it to be in second normal form if it is in first normal form and is not dependent upon a portion of the primary key. And so when I say a portion of the primary key, this is specifically referring to composite keys. When you're using multiple attributes, multiple fields to create a primary key. We've talked a little bit before about composite keys. And again, that's all it is. Instead of just using a single field as a unique identifier, the primary key, we're going to use multiple fields, multiple columns to uniquely identify each record, right? So instead of having a student ID, for instance, we could have a student first name and a student last name, and then maybe a student address or something like that, right? And so together, collectively, all of those fields will uniquely identify a record, where individually they probably don't, right? That's what a composite key is. And so second normal form is in reference to that. For all of our relations, all of our tables that are just using single field primary keys, they are essentially by default in at least second normal form. And so then we have our third normal form. So a third normal form is being in at least second normal form, but also having only determinants that are contained as candidate keys. And so remember, a candidate key is essentially something that could be used as a primary key, and that includes composite keys, right? So it's said to be in third normal form when it is both in first and second normal form, but all of the determinants in the relation contain only candidate keys. Then it's in third normal form. And then finally, fourth normal form. Again, if a relation is in all, first, second, and third normal form, and it contains no multi-valued dependencies, then it's considered to be in fourth normal form. So to kind of explain this in more simple terms, right? Normalizing our database, and that's what we call this with all of these normal forms. We refer to it as normalizing our database. It's all about breaking our database into multiple tables where each table is essentially its own separate topic, right? Its own separate theme, right? And so this is all about removing duplications and things like that. Having, first normal form is all about making sure that we don't have any columns that, are duplicates of each other, and that we are creating tables for each group of information, essentially. And then, each subsequent form after that is just adding on, additional layers of filtering and normalization processing. So to kind of bring it back to the example I used in the beginning here, if we had a database in a relation, a single table that held, a student ID, their student name, the professor name, the professor, the department, and then the major of the student, right? That's a lot of information. There are a lot of themes there, and they should not all be in one single relation, right? So we would want to break it up so that we have all of our tables are its own unique group of information, its own unique theme, right? And so what I mean by that is we would have a table just for the student, where we would have the student ID and the student name, and then maybe the professor that's assigned as the student advisor, right? And then we would have another table for each professor, where we would have the professor ID and the professor name and the department that they teach in. And then we could have the department, right, where we have, the different professors that are in each department, the different students that are in each department, right? And so now we've created, we've separated out all of these groups of information, and then we can tie them together. We can create these relationships by using foreign keys and things like that. And so, this is what we're used to seeing at, all the databases that we've been using and going through up until this point. This is what we're used to seeing, but getting there, creating these tables, that is the normalization process. So kind of just helps explain how we've gotten to this point where we've kind of already been at. All right, so that's how we can avoid data modification anomalies by normalizing our databases. Very effective way of doing that. So I hope this was beneficial to you guys, and I want to thank you for watching.